Our next speaker is Jean-Marc Ferret, and he's going to talk about Certitude, functional qualification with formal verification.
Thank you. So, here are the topics I will talk today. And to make the presentation more real or more interesting, I've created a small test case, which currently is FIFO, to experiment. And it was created under schedule pressure because I had to deliver the presentation. So I created both the RTL and the verification environment. And of course, as any good verification environment, I leveraged what I could from a previous version. We can see later in the presentation what could be the consequences also of those things. So my FIFO is a quite simple FIFO with read-write enable, and all the outputs are clocked just to make it slightly more interesting regarding the flags. So maybe the first question, which is probably quite obvious for verification engineers, but why are you doing verification? Well, people are doing verification because the designs are created by humans, and humans make mistakes. There's no way around that. And the design have bugs. However, customers or consumers, what they want are bug-free designs, safer, more reliable products, and of course, from generation to generation, well, there is a tendency, I'm not sure where it is coming exactly, but to add more features, more powerful products, and complexity increase. So how is it possible to satisfy those constraints? Well, one way to make a design with less bugs would be to have computers making the design, which is kind of a joke. Because clearly computers are missing the creativity to make designs. Well, you may consider that using ESL is a way to do that. Another possibility is to wait for bugs to be reported by user, but clearly it's missing the second point, which is that consumer want bug-free design, so not a good option either. And the last possibility is to audit the design to squeeze out the bugs. And this is exactly what people are calling verification. It's a kind of auditing of the design. And verification is a set of techniques to find bugs in the design. But the key point here is that the human contribution is still primordial, meaning that all the big aspects of the verification, like specification, architecture of the verification environment, methodology which are used, are all decided by humans. And only the implementation aspects are led to the computer. So the computer is really the assistant, which is here to check, for example, things like test generation, check the simulation results, which is absolutely great and mandatory because nobody can analyze millions of clock cycles. Computer will also tell you if a property is true or not on your design. But there are some little hurdles with those aspects. First hurdle is that the size of the problem and the available time is usually not matching together. And the other question is, how do you measure verification? And I think Harry Foster this morning mentioned it very clearly. If you can't measure something, you cannot improve it, you cannot act on it. So clearly measuring the quality of the verification is a key aspect. Second aspect, I would say, is it's nice to be able to measure something, but what is the meaning of that measurement? And if you don't know the meaning of the measurement, then maybe you are not measuring the right things. And then how to combine the different measurements. Well, the first aspect I mentioned previously, which is the size of the problem and the allocated time, transform what could be seen as a technique into an art. So what to verify in your design, at which level, with which method. There were a number of contributions already on this today. And really verification is a risk management exercise. So what to skip, when to stop. Like François said this morning, 60 states out of 1 billion states. clearly it's, you must be very careful in choosing. And of course, as you are under schedule pressure, you want to combine techniques to make the verification as efficient as possible, because every technique has its own sweet spot, has its own location where it works better. So by combining the strengths of multiple techniques, you're also able to do a verification more efficient and more quickly. But verification being conceived by humans is also subject to bugs. So like missing properties, missing broken checkers, missing tests or missing scenarios. And those aspects are, I would say, are even more difficult to catch, because when you have a bug and you have clear evidence of a bug, well, in a way you just have to analyze it, which some people would already consider challenging. But when everything seems okay, then what can be wrong if you don't have any evidence? But those bugs can easily hide bugs. So bugs in the verification environment can easily hide bugs in the design. So how to gauge the efficiency of the verification? Well, the way to do that is to implement some metrics to estimate what was done. So there are a number of metrics, many of them having been mentioned today. For example, bug rate, functional coverage, which probably apply mostly for the dynamic world, structural coverage of the design, like line, block, condition, expression, etc. But the question when we are talking now about formal is which of those ones are making sense with formal? Because all those metrics have been initially developed for dynamic verification. Well, one point I would question first is a metric to estimate what was done. Really? Really what was done? I would say that all those metrics are to estimate or to know what was not done. So if something is not covered, it is not verified. I guess everybody would agree on that. But very often people tend to wrongly negate that statement and consider that when it is covered, it is verified. No, this is wrong. If it's verified, it's certainly covered. Otherwise, the coverage metric may not be so good. But when it is covered, you don't know if it's really verified. And the second aspect is how to combine those metrics. So this is related to my other question, which is what is the meaning of those metrics? So say that you have 80% line coverage and 90% toggle coverage. Is better or worse than having 90% line coverage and 80% toggle coverage? And how do you combine metrics between dynamic and formal verification environment? One question that was mentioned by some people today, so Harry and Jörg, is what are the achievable scores or the problematic of screening or pruning the coverage points which cannot be reached? And then how much is the metric score telling you about the verification effectiveness? So once you have reached, say, 100% line coverage, should you be happy? Should you continue to do verification? It's a difficult question to answer if you're just looking at line coverage or this kind of metrics. Now, regarding formal verification by itself, I think that there are a couple of questions which are worth asking and thinking about, and I will present some of them at least in the following slides. So regarding the properties, how many properties are needed to verify your designs, and which one do you have to write? So yes, you take a specification, read it, extract a number of aspects, but when are you done? It's again, it's a very difficult question because you will not have clear evidence that you are missing something. Then the other aspect when you are using your formal tool is that a formal tool is like an oracle which is answering the question you are asking it. So if you ask all the right questions, you will get very valuable answers. If the questions are somehow not so good, or if you are missing some good question, well, the tool will not tell you. So what do you do? Then there is another aspect which is commonly said about formal verification is that you don't have stimuli. Again, I would question that statement and would prefer to say that there is no explicit stimuli, but there are certainly implicit stimuli. And all the implicit or all the stimuli combinations are considered as being valid unless they are restricted by constraints. But the first attempt when you run a formal property checking tool is you write some properties, you try to prove them, and if everything passes, great. Well, let's say that you have a set of properties, you don't have, you haven't written any constraints, all the properties are proven. What does it mean? Let's consider that for the design you are verifying, you know precisely from specification that some combinations are not valid. There is a very famous motto among designers, which is garbage in, garbage out. So now you are also saying that you haven't written any constraints, which means that even though all the possible input stimuli are not valid, you are able to send garbage to the design, and the design is good enough to only generate valid outputs. That's an interesting point, and maybe a first indication that in a number of cases you are only seeing both properties and probably constraints. Another aspect which is quite often used with formal verification tools is coverage point. So you can automatically, you can ask the formal tool to reach a number of aspects. So for example, the preconditions of your assertions. Well, what is the value of those coverage points that were reached if you don't have any constraints and your design doesn't accept all the possible stimuli combinations? I would question also that aspect, because if you don't have any constraints, then a number of those covered points could be covered due to illegal stimuli. And clearly, points which are covered due to illegal stimuli should not be considered as covered. Another aspect which is, I found at least a bit annoying, is that you don't get execution traces or waveforms if a property is a pass. So you get those waveforms only when you have a failure. So for counter examples, which means that whenever a property tool is returning to you that everything is fine, you have to believe it. Well, I guess there are still bugs in the tool also. I'm pretty sure that tool providers are extremely careful on those aspects, but well, probably have bugs, which is a bit annoying. But probably the most blatant issue is that, well, you don't know if you have done the right job or if you have asked the questions in the right way to the property tool. So if you have a bug in your property, you may not notice it because you get a pass. If you get a fail, you have something to debug, you look at it, maybe there is a problem in the design, maybe there is a problem in the assertion, but one way or the other, you will get to the bottom of it. When you get a pass, you have no indication about those aspects. Then three additional things which are somewhat linked together is how much of the design is used to get the proof, and which aspects of the design are really verified. So you have a set of properties. What is really verified by this set of properties? And I would also say that white box verification is a misleading friend. I say remains because it is a misleading friend when you're doing dynamic verification, but it's the case also here. So consider that you have two sets of properties, P1 and P2. P1 entirely verify B1, P2 entirely verify B2. Well, can you say that you have also entirely verified the enclosing box? I don't think so. And say that for P2, you get a proof by just considering B2. Well, it's very easy from this example to create two variants of the same design, probably one being buggy. So let's say that in normal condition you have this input connected to B1 upper input and so on. Well, to create a buggy design, just imagine that here you are connecting B1 upper output to B2 lower input. Well, P2 would still be passed and P1 would still be passed. But probably you already have two different designs, only one which is correct and may not even be correct. So back to my small design and test case. Here I am considering only one property, which is that on my FIFO I can't have the FIFO full and the FIFO empty both asserted at the same time. And this is kind of a high-level view of my design with some combination logic here. And well, I have an inverter between the internal signal, which is deriving the FIFO empty output, and the FIFO full output. Well, unless you are designing a FIFO which has only one word, which is only one word deep, this is clearly not a very satisfying behavior. Now let's consider the read enable and write enable. Well, those two signals can influence through the cloud of logic, which is here, the FIFO empty and the FIFO full output. Okay, so this is called the cone of influence for the property which would be connected on those two outputs. But this is not really what was verified by the formal tool. So now let's consider what the formal tool has to take into account to be able to say, yes, this property is done on that design. Well, the formal tool only has to get those aspects or this part of the design. And this is an important point to keep in mind. Maybe surprising is that there is a difference between the cone of influence and what is verified. And let's consider that what is verified is more or less equal to the reduced code. I'd say more or less because I don't think it's even completely true. Well, in this case, this is somewhat verified, but it's still buggy, so I cannot say that it's fully verified. So how to find the reduced code? Well, there is one way to find the reduced code, which is to inject artificial bugs in the design. And at least one property should fail. So if you have only one property, as I have, well, that's quite easy. And when you have one property which is failed, this is good. Now, if all the property passes, then, well, this is bad, and it's bad in several ways, but now you have some evidence of a problem. It's bad because the same bug would be missed, and sometimes it can be quite shocking. And also bugs with similar effect could be missed too. So the question now, once you have those evidence, is what's wrong? What am I missing? So am I missing properties? Am I over-constraining the design? Is there a mismatch between what the designer has intended to do or his interpretation of the specification, my own interpretation of the specification? But in all the cases, more verification is needed, or more checks maybe. So those could be done either in dynamic or formal, or a combination of those two. So Certitude will work by injecting those artificial bugs, and some may be bigger than others, and by enabling one of them and running this modified version of the design through the verification process. So if at least one property fails, this is good. If all the properties pass, again, there is a problem. So this is a kind of result that you can get with this design and the single properties that I have specified before. And for example, we stuck at 0 on FIFO empty or FIFO full output, which are non-detecting. Non-detecting meaning you get a pass. Certitude will also tell you by querying the formal tools, which faults cannot have any influence or cannot result in any failure because there is no property connected to those outputs. Slightly more in detail, where we take the RTL code and we modify it. So for example, for an output, you have a function which is, or functionality which is connected to it. We will disconnect that functionality from the output and stick the output to 0. Same principle apply for other type of modification, like for example a condition here. where we replace that condition by a true, which leads to only exercise that functionality and completely removes that second aspect. One key point here is that the same principle and definition is applicable to both dynamic and formal verification. So it means that it's very easy now to combine results that you can get from dynamic and formal qualification. So in my case that I have presented previously, I will show you the type of results that I've got. So these are the properties I've leveraged from previous verification. It's not the complete property for those who are knowledgeable in SBA. I've removed some aspects but kept the central part of the property. So I've used those properties on my FIFO, and these are the results that I got after qualification of the verification environment. So some aspects of the design are not verified by my static verification environment. This is expected because for the static verification environment, I focused only on the flags and decided that the dynamic part of the verification environment would focus more on the data aspects. But I also get 14 non-detected faults out of 83 faults for that FIFO. And currently the stuck at 0 on FIFO empty and FIFO full flags were not detected. And really I was quite shocked by that. And at first I even thought that there was a problem with the formal tool I was using. So I immediately jumped on another one and checked that it was delivering me exactly the same result. So I had to really question what was going on. And currently this set of assertions that would have expected to catch those aspects were clearly not. So when you look at the Certitude report, you get something like that with, for example, the outputs, and you can get details on the faults which are injected on the outputs. So you can see that the stuck at 1 or the negative on the in this case, it's a FIFO empty flag are detected, but the stuck at 0 is not. And if you're looking at the whole qualification, so in this case I have qualified all the faults here, you can see a number of white dots highlighting many transformations of the design that I could do without being noticed by the set of properties that I'm using. So that was a little bit shocking again, and I decided to add two properties. This time those properties were not at all looking at the FIFO empty or FIFO full flag as an input, but only as a result of an action. So I parameterized the FIFO to be forward deep and said that if I don't get any re-enable, while I'm getting 4 right enables, then I expect the FIFO full flag to be asserted. Either right at the moment if the FIFO was empty or even before, but at least after 4 cycles it must have been set. Same for the FIFO empty, and well, I would say almost of course, as soon as I plug those two FIFO into those two properties into the property checking tool, then I got 2 failures. So now I had something to debug, and debugging those 2 failures boils down that this was leading to problems in some for corner case value of the read pointer, and I had to replace it by a much cleaner way to write the design. I also discovered other bugs through the dynamic verification environment, so this time on the data part. And after fixing my verification environment and rerunning the qualification, now I have somewhat more faults, but more important, I'm only getting 2 non-detected faults. So I was significantly able to increase the quality of the verification. So this is the report before, and this is the report after. Currently, those 2 faults cannot change the design of the behavior of the design, and even the full condition could be removed. I put that comment when I created the FIFO, thinking, yeah, I think it's not necessary, but I prefer to keep it. Somewhat maybe using 2 security measures instead of ones, but later I've used a formal tool to prove that really those lines are redundant, so they should be removed. So I did the same with my dynamic verification environment. I'm getting a FIFA almost full flag from Mike here. And I found that I was getting again some non-propagated, well, this time non-propagated faults, non-detected faults. So again, some aspects of the verification environment needed to be improved. And once I've improved them, then I got those results. Currently, the 2ND faults are common with green with static verification environment, so I don't really have to worry about them. And the 2 non-propagated faults are due to the faults which really cannot change the behavior of the design. So as a conclusion, I would say that Certitude really helps in this case to understand what part of the design are verified, and I feel that it is even more important when you're using formal verification because you don't have that feedback that is provided by dynamic verification, where you can look at waveforms and at least at the beginning of when you are starting to have something working and say, yes, it is really doing more or less what I want. So seems to be under control. With formal verification, you don't have that feedback. Second aspect is that addressing the verification issues which are pointed out by Certitude will allow verifiers to discover design bugs. And in this case, I want to make that clear that I consider that the bug I've discovered by using the formal tool, I would probably have missed them if I would have been using only dynamic verification, because they needed a very specific condition to be triggered. I have noted, however, that in real life, this condition would have occurred at some point. Third point is that it's easy to merge metrics from dynamic and formal verification environment to get a global picture of the verification strengths and weaknesses, which allow you to address those issues where they are it's best suited. So either by using formal or by using the dynamic verification. And it's allowing you to optimize the verification effort. So instead of having 2 different verification environments that you push as much as you can really combine the results. And Certitude provides a strong unified metric for both dynamic and formal verification because it's using the same definition. Okay. Questions?
Thank you. Thank you, Jean-Marc. Do we have any questions from the audience? Do you want to speak or do you want to shout? Okay.
So, can you elaborate a bit more about your part model? So, do you consider relations with creators, or is just stack for some actions?
Can you repeat the question?
So the question is, what is the model? So we are injecting all sorts of mutations. Some of them are stuck-at, some other can be considered as being stuck-at even if they are not labeled like that, and some other are operator mutations. So we have a range of faults that we can inject in the design.
Any more questions? Okay, go ahead. Yeah.
So the question is, how does it scale? It scales reasonably well. Certitude has been in the field and used by customers since more than 7 years now. So I'm quite confident to say that it's applicable on industrial designs. No. Currently it's that, and people are so confident in the quality of the result they can get that they gave us many POs in advance. What I would say it's something that I didn't believe the first time I heard about Synopsys, about Certitude, and currently I was still. You will see why I made these lapses. I was still in Synopsys the first time I heard about it, and I heard from a customer who told me, oh, you know, there is this new tool, they take a design, they put a bug in it, and they run test. And I said, are they not crazy? What do you expect from buggy design but failing test? Well, currently, to my surprise, and probably to the surprise of many people who have evaluated Certitude, when you take a design, you break it and run it through a verification environment, unfortunately, you get too many passing tests, which leads or has led to a number of optimizations and ways to order false, ways to not qualify everything. So there is a number of optimizations which are done inside Certitude to avoid this scalability issue. And of course, we are leveraging all this knowledge to the formal aspects.